Okay, so we've already learned how to assign oxidation numbers. We've learned how to write half reactions and how to balance redox reactions in acidic conditions. So let's look at how to balance a redox reaction in a basic solution. All right, and that's just our abbreviation for solution. Now, remember that bases contain a hydroxide ion, so this is going to be important in terms of our balancing. So our first step is we are going to balance the same way as an acid redox. So we start balancing as the reaction as if it is in an acid. Now, acids contain hydrogen ions, bases contain hydroxide ions, so we are going to balance out the hydrogen ions by adding hydroxide. Finally, we can put the two half reactions together and cancel things on both sides, reducing as needed. Okay, so let's look at this example, and we're going to use permanganate ion again. This is a pretty common ion to use. Plus C2O4, 2 minus, which is our oxalate ion. And this is going to give us MnO2 and carbonate. All right. So our first step is going to be to assign oxidation numbers, and you'll notice the net ionic equation's been provided. So oxygen is a -2, 2 times 4 is 8. The overall charge of the ion is a -1, so manganese has to be a +7. +7 minus 8 is -1. Oxygen is a -2. The overall charge of the ion is also 2 minus. So my carbon here is going to be a +3. 3 times 2 is 6. A +6 minus a -8 is -2. My oxygen is a -2, making my manganese a +4. 4 minus 4 is 0, and this is a neutral compound. Notice it's a solid. And then my ion here, carbonate oxygen, is a -2. 2 times 3 is 6. So carbon has to be a 4 because 4 minus 6 does give me the charge of 2 minus. All right, so my first step here after assigning oxidation numbers is to figure out where my electrons go, what's being lost and gained. So we notice here that manganese is becoming less positive or more negative, and carbon is going from a +3 to a +4. It is becoming more positive. It became more positive because it lost electrons. How many electrons? 1. It went from a +3 to a +4. And manganese went from a +7 down to a +3 because it gained 3 electrons. All right, so my reduction here is going to be the manganese, and my oxidation is this carbon. All right, so let us write our half reactions. We have MnO4 minus is going to become, it gains 3 electrons, so that is a reactant, to become MnO2 Manganese dioxide is how we call that, the common name, although not the IUPAC name, but that is a common name that you'll hear. Then we have our oxalate ion. It loses one electron to become a carbonate ion. All right, now we need to balance our electrons. So if I multiply my second equation by 3, that will balance my electrons. But before we do that, we also have to do one additional step in this problem. Notice carbon is not balanced. So we want to balance everything other than the hydrogen and oxygens before we do our multiplication, which we've already determined is going to be by 3. So if I have 2 carbons on the left and I have 1 carbon on the right, I need to put a 2 as a coefficient. And now that's also going to change my electrons. 2 times 1 is 2, so I have 2 electrons. So now that's going to affect my overall balancing. My carbon, my second reaction here is still going to be multiplied by 3. But I have 2 total electrons, so I'm going to have to multiply my first reaction by 2 in order to get those electrons to balance. Now, I'm going to rewrite everything on a whole nother line, making my work very clear to the reader, because my job as the student is to make things as crystal clear to the reader as possible. So I have 2 manganese permanganate ions. I have 6 electrons. And I have 2 manganese dioxides. I have 3 oxalate ions. I have 3 times 2 is 6 electrons and 6 carbonate ions. Now, my next step is to start balancing as if I am balancing it in an acid. So I am going to balance my oxygens by adding water. 4 times 2 is 8 oxygens. 2 times 4 is 4 oxygens. So I'm going to add 4 waters to the product side in order to get my oxygens to balance out. And then I'm going to balance my hydrogens by adding hydrogen ions. So 4 times 2 is 8. So I'm going to have 8 hydrogen ions. My final step here, we are going to balance the hydrogen by adding hydroxide. So I have to take this one step further. So if I have 8 hydrogen ions, I have to add 8 hydroxide ions to balance that out. But what I add to one side, I have to add to the other side. Law of conservation of mass. So now let's look at my second step. 4 times 3 is 12 oxygens. 6 times 3 is 18 oxygens. So I need to add 6 waters to the reactant side in order to have the correct number of oxygens on both sides. Since I added 6 waters, I'm going to balance these hydrogens by adding hydrogen ions to the other side. Now, my final step, I have to balance these hydrogen ions with hydroxide. So if I add 12 hydrogen ions, I also have to add 12 hydroxide ions, and I have to add it to both sides. Again, law of conservation of mass. Mass is not created or destroyed, it simply rearranges. So here we go, my friends. Now let's look at this. 8 hydroxides and 8 hydrogens give us 8 waters. 12 hydrogens and 12 hydroxides give us 12 waters. Now we are going to go through and we are going to combine everything into one nice, fun, complete ionic equation. I have 8 waters plus an additional 6 waters. So 8 plus 6 is 14 total waters on the reactant side. Plus 2 permanganates plus 6 electrons plus my 12 hydroxide ions. Be careful, you have already added water. Don't add it again. Plus my 3 oxalate ions. And now we are going to do the product side. I have 2 manganese dioxides. I have 4 and 12. 4 plus 12 is 16 total waters. I have 8 hydroxides. I have 6 electrons and 6 carbonates. Again, these waters have already been added as part of my 16, so I do not need to add them again. Now we need to go through and start canceling. I have 14 waters on the left and 16 on the right. So these 14 go away. This 16 reduces down to 2. 14 or 16 minus 14 is 2. All right. I don't have any permanganates on both sides. My electrons are the same on each side. I have 12 hydroxides on the left side, and I have 8 on the right side. So those 8 go completely away. This 12 reduces down to 4. And now everything else is just by itself a singleton. So now I'm going to simply rewrite everything, making sure to include my states of matter. I have 2 permanganate ions, which are aqueous. I have 4 hydroxide ions, which are aqueous. I have 3 oxalate ions, which are aqueous. I have 2 MnO2, which in the problem, it told me it was a solid. Plus, I have 2 waters, which are a liquid. And I have 6 carbonate ions, which are also aqueous. So overall, this is my final equation for this example, balanced in a base.